Welcome to EDUCARE. Today, in this tutorial, three-phase transformer connection and phasor diagram part 2 will be explained. Already I have completed part 1 tutorial. Without knowledge of that video, you may not be able to understand today's class. So I request, please go through that video. Start the connection and phasor diagram of three-phase transformer DD6. D capital letter, that means high voltage. D small letter, that means low voltage. And D means delta. D means delta. That means high voltage will be delta connected and low voltage will be delta connected. And 6 means 180 degree phase difference, as explained in part 1 class. First I draw the high voltage winding. High voltage will be more number of turns. Suppose this is the phase A, this is the phase B, and this is the phase C. This is starting of phase A denoted by A1, the ending of phase 2 denoted by A2, and B1, B2, C1, C2. As I explained in the part 1, the end of the winding is identified by dotted. This is the end of winding, that means dot terminal will be there. End of winding B, dot terminal. End of winding C, dot terminal. For low voltage winding, that will be less number of turns. This is the phase A, a small letter. Starting is A1, end is A2, and end is represented by a dot. This is the B phase. Starting is B1, end is B2, and end is represented by a dot. And this is the C phase. Starting is C1, end is C2, end is represented by dot. Now, for delta connection, A1 will be connected to B2, B1 will be connected to C2, and C1 will be connected to A1. Sorry, A2. That is the delta connection. Here for DD6, be careful. Here A1 is connected to B2, but here A2 will be connected to B1. Here A2 will be connected to B1. B2 will be connected to C1, and C2 will be connected to A1, like this. Here the input is given this terminal A2, B2, C2, that is the input. Input will be the dotted terminal. And output is taken from A1, B1, C1, not A2, B2, C2. If I take output from this, then it becomes DD0. So this is your output, and output will be undotted. Here dotted, this is the undotted. Output is taken from C1, that is output will be undotted. As I explained in part 1 class, for drawing a phasor diagram, low voltage phase voltage must be parallel of high voltage of phase voltage, not the night voltage. For drawing the phasor diagram, I arbitrarily draw the phasor diagram of high voltage. Okay. First to draw the high voltage phasor diagram arbitrarily. Suppose this is the A phase. And this is the A1, this is the A2, and this is your A phase phasor diagram. Now here A2 is connected to C1, therefore it will be the C1. A1 is connected to B2, here B2. Now C1 and C2 will be, phasor diagram will be like this. C1, C2, this is your C phase. Here C2 is connected to B1. C2 is connected to B1. And therefore B1, B2 phase will be like this. Therefore ABC phase sequence. Here ABC phase sequence. This is B phase. ABC phase sequence. To draw the phasor diagram of LB line voltage, LB winding, the LB phase voltage, what is the phase voltage? A1, A2. What is the phase voltage? A1, A2. This will be exactly parallel. That means here high voltage is A1, A2, capital letter. The small A1, A2 will be like this, parallel. Okay. This is the A1, A2. This is your A1, A2. This is the phase A. Since it is exactly the parallel, this will be parallel of this. Here A2 is connected to B1. A2 is connected to B1 and A1 is connected to C2. A1 is connected to C2. Now here the C2 C1, this is the C2 C1. High voltage C2 C1 and low voltage C2 C1 will be exactly parallel. This is the C2 C1, that will be the C2 C1. C2 C1. This is your C phase. Now here C1 is connected to B2. This is connected to B2. Now here B1, B2, high voltage phase voltage B1, B2 and low voltage B1, B2 will be exactly parallel. Here this is the B1, B2, B1, B2 will be exactly parallel of this B1, B2, B1, B2. This is your B phase. Be careful, for drawing the phasor diagram, the phase voltage will be exactly parallel. For finding out the group, I will see the line voltage. Here, what is the line voltage? A1, A2, B2, B2, C2 or A2, C2. What is the line voltage? A1, B1, B1, C1 or A1, C1. I take any line voltage. I take the line voltage of C2, B2. Suppose B of C2, B2. And here what is the line voltage? Line voltage of B of C1, B1. Okay. Here C2, B2. This is C2, B2. That is your high voltage C2, B2. What is the low voltage line voltage? It is the B of C1, B1. What is C1, B1? This is the C1, B1 in this direction. From C1 to B1 in this direction. This is the low voltage C1, B1. That means if it is 12 o'clock, then it is the 6 o'clock, opposite direction. Opposite, 180 degree phase difference. 180 degree phase difference. If 180 degree phase difference, then it is a group 6 as I explained in part 1 tutorial. Therefore, it is D6. Now start OII0 by OII12. Here high voltage will be star connected, low voltage will be star connected and 0 degree phase difference will be between high voltage and low voltage line voltages. Suppose this is the A phase A1, A2, end of winding dotted. B phase B1, B2, end of winding is dotted. C phase C1, C2, end of winding is dotted. For star connection, A1, B1, C1 will be short circuited and neutral point is taken from here. This is a low voltage A phase A1, A2, end of winding dotted. B phase B1, B2, end of winding dotted. C phase C1, C2, end of winding dotted. Again for star connection, here A1, B1 and C1 will be shorted and neutral point is taken from here. This is your input terminal A2, B2, C2. This is your input terminal which is dotted terminal. Now output is taken from A2, B2, C2. This is your output. It is also dotted terminal. To draw the phasor diagram, I will arbitrarily draw the phasor diagram of A1, A2. Suppose this is your A1, A2. A1, A2, A phase. Now here A1, B1, C1 is the same point, shorted. A1, B1 and C1, same point. Therefore, B1, B2 will be like this. B1, B2 will be like this. This is the B phase and C1, C2 will be like this. C1, C2, this is your C phase. The line, the LV phase voltage is exactly parallel of HV phase voltage. Here A1, A2 will be exactly parallel of A1, A2. Therefore, this is your high voltage A1, A2, high voltage A1, A2. This low voltage A1, A2 will be exactly parallel. So, I draw this is A1, A2, A phase. Here A1, B1, C1 are the same point, shorted point. A1, B1, C1, same point. Here this B1, B2 and this B1, B2 will be exactly parallel. This is your B1, B2. This C1, C2 and this C1, C2 will be exactly parallel. This is C1, C2. Therefore, A phase, B phase and C phase. Here A, B, C phase sequence, A, B, C phase sequence. Here A, B, C phase sequence. To finding out the groups, I will take the line voltage. I take the line voltage of C2B2 as previous case. Here this is your C2B2. This is your C2B2. Here the line voltage is C2B2. This is your C2B2. This is your C2B2. So if I draw, that means C2B2 high voltage line voltage C2B2 and LV line voltage C2B2 are in the same phase. That means if I draw the clock diagram, it is 12 o'clock, it is 3, 6, 9 o'clock. The high voltage is at 12 o'clock C2B2. Then the low voltage C2B2 will be the same phase C2B2. And it is therefore it is YY 12 or YY 0, 0 degree phase difference, YY 12 or YY 0. Start YY 6. Y means high voltage star connected, low voltage star connected, and 6 means 180 degree phase sequence. Here A phase, A1, A2. HBB phase, B1, B2, C phase, C1, C2. End of winding A2, B2, C2 will be dotted. For star connection, A1, B1 and C1 will be short circuited and neutral point is taken from here. This is the low voltage A phase, A1, A2. Low voltage B phase, B1, B2. Low voltage C phase, C1, C2. End of winding is dotted, end of winding is dotted, end of winding is dotted. For YY6, A2, B2, C2 will be shorted, not A1, B1, C1. Be careful. Here, this A2, B2 and C2 will be shorted and neutral point is taken from here. Here, input is given to the terminal A2, B2 and C2. This is your input terminal. Input will be the dotted terminal. Here, dotted terminal. Here, output is taken from A1, B1, C1. This is the undotted terminal. This is your output undotted. Okay. Now, I will arbitrarily draw the phasor diagram of HV phase voltage A1, A2. Suppose this is the A1, A2. A1, A2. Here A1, B1, C1 will be the same point A1, B1, C1. Therefore, the B1, B2 will be like this. This is the B1, B2 and C1, C2. C phase will be like this C1, C2. This is your A phase. This is your B phase. This is your C phase. Now, the LV phase voltage A1, A2 will be exactly parallel. This is your A1, A2 and it will be exactly parallel A1, A2. This is your A1, A2. Here A2, B2, C2 at the same point A2, B2 and C2 at the same point. This voltage B1, B2 will be exactly parallel of B1, B2. Here this is your B1, B2. Therefore, this B1, B2 will be exactly parallel like this B1, B2. This is B2 and B1, B2, B1, B2, B1 exactly parallel. And this C1, C2 will be exactly parallel. Here this is the C1, C2, that means C2, C1, C2, C1 exactly parallel. Here this is your A phase, this is your B phase, this is your C phase. ABC phase sequence is ABC, ABC phase sequence, ABC phase sequence. For finding out the groups, I will take any line voltage. I am taking for every cases I am taking the line voltage C2, B2. You can take A1, A2, B2 as you like. I am taking C2, B2. Here C2, B2. This is your C2, B2 in this direction. C2, B2. Here C2, B2 will be in this direction. C2. What is the line voltage here? C1, B1. C1, B1. What is the C1, B1? This is C1, B1 in this direction. This is your C1, B1. That means C1, B1 would be like this. If it is a clock, it is a 12 o'clock, it is 3 o'clock, 9 o'clock and 6 o'clock and 9 o'clock. If the C2B2 high voltage line voltage at 12 o'clock, this is the HB line voltage, then the LV line voltage will be in the opposite direction, C1 B1. Here it will be the opposite direction, LV. Therefore, it is a star connection. It is a star connection. Y, Y. It is reference 12 o'clock, but LB is in the direction of 6 o'clock. It is 6. Therefore, it is YY 6.